How are you, grade 9s? I hope you guys have been well. I have also been well, just apart from the fact that I miss you guys. I miss you guys here at GSMC. We miss you, grade 9s. We wish that this whole COVID-19 thing would finish and that you guys would come back to school. Because right now I'm standing in your DH. I'm standing in your DH. Sure, you know, we've been here several times before, but the place is just so empty without you guys. The place is just so empty. But now what we have decided to do as a school is that we have decided to make these video packages. Okay, we have decided to make these video packages that we're going to send to you. I'm sure that the fact that you're watching it right now means that you have received this video package. And along with this video package is a Word document or a PDF document that is notes for this lesson. You also have other videos for the next lessons which I've already recorded for you guys, so that you can be able to understand the different concepts that we are going to be teaching, and that way we allow and we ensure that the syllabus continues to move even though we are all under the lockdown. We are all in the lockdown. Even here in Umadala village, we are in the lockdown. Okay? So I would like to welcome you guys to our first lesson for grade 9 physical science with your teacher, yours truly, Marshall Kandiani. Right? Welcome guys, welcome. Okay, so today in our first lesson, we are going to be looking at decomposition reactions. Decomposition reactions. I hope that you guys right now are holding a document, a PDF document on decomposition reactions. It has the notes that I've prepared. There are also spaces. If you look at that document, there are spaces where you guys will have to fill in, because there's going to be practical activity. That's why I'm here. I'm going to demonstrate a practical for you guys on decomposition reactions. Okay, but before we get carried too far away, let's look at what today's objectives are. What is our purpose for today's lesson? So in today's lesson, by the end of the lesson, you guys should be able to define the term decomposition. You should be able to define the term decomposition. You should also be able to describe decomposition reactions. You should also be able to describe decomposition reactions. The beauty of it is that I have a practical here. I'm going to show you, right, an example of a decomposition reaction. Right? In this lesson, we'll look at the decomposition of copper carbonate. Right? So by the end of this lesson, when you have watched this video and you have watched it again, you will be able now to know what is a decomposition reaction. Right? Then the other objective is that as I'm showing you this decomposition reaction, you should be able to observe the changes that take place. As with any scientist, if you are conducting a practical, right? If you're conducting a practical, you should be able to observe, to say, okay, initially there was a substance but it had this color, right? But then after heat was applied, then the color changed and it became this color. Initially, was the water boiling or was the water cold? Those are observations that you make as a scientist. Those are observations that you make as a scientist. Then after we have finished talking about the different types of decomposition reactions, then you should also be able to write down the word equations. You should also be able to write down the word equations for the decomposition reactions. Okay, so let us go guys. First lesson, physical science, decomposition reactions. So the first thing that we need to know is, what is a decomposition reaction? What is a decomposition reaction? A decomposition reaction is basically the breakdown, the breaking down of a large compound into simpler compounds or even its derivative elements. Okay, let me say that again. All right, let me say that again. We're talking about breaking down. You know, when you break something, sometimes you can pick up a brick and it's very big, but then you know this brick is too big and I only want to use maybe a part of it, right? So you break the brick maybe into 2 pieces, maybe into 3 pieces, right? Then when you break it down, it means that effectively a decomposition reaction has, in a way, taken place there, right? But now, if you remember or if you recall from our grade 8 physical science, we talked about how sometimes we have physical changes and how sometimes we have chemical changes. When we have Physical changes, we say you might take, I'll give you a common example, where you can take iron and you mix it with sulfur. Right? Iron, you mix it with sulfur, and then what you get, because it's a mixture, is just iron that is mixed with sulfur. Right? It's not a compound, it's still the element iron, it's still the element sulfur. Right? You have not necessarily formed a chemical combination, it's just a physical change, it's not a chemical change. Now, what we have with decomposition reactions is a situation where we have compounds. Right? A compound, a substance that is composed of two or more elements that are chemically combined. I hope that you guys have been reading your notes. I hope that you've been going through your grade 8 notes, because all of these things are linked. All of these things are linked. We move from grade 8, we move to grade 9, but all of the material is linked. Therefore, do not lose your grade 8 material, because you will still need it even now. Let's go back to decomposition reactions. Okay? So, when you have a compound, sometimes there's a compound, but then in that compound, today we'll mainly look at copper carbonate, and then we'll also look at copper sulfate. But what we need from the copper carbonate is the copper that is in the copper carbonate. So we need to have decomposition reactions. We need to have decomposition reactions where we can break down this copper carbonate to be able to remove the copper from the carbonate. Okay, so copper carbonate is a combination of the element copper, the element carbon, and three elements or three atoms of oxygen. Right? Its symbol or its equation, the formula would be CuCO3. That is copper carbonate. But what we would want is the copper only. So decomposition reactions, as I have now stated, these are reactions in which a compound is broken down into simpler compounds or into its base elements. Take, for example, water. You can have a decomposition reaction where you have water being broken down. We call it electrolysis. Electrolysis, we pass a current, we pass electricity through water, and then the water is able to be collected in the form of hydrogen in one test tube and in the form of oxygen in another test tube. These experiments, you will also do them as we go on to grade 9, grade 10. We'll be able to do some of these experiments. And you can even Google this, you can even look on YouTube, you can find electrolysis reactions, and then you can see, okay, this is also a decomposition reaction. Right? But for this one, today, we will be looking at the decomposition of copper carbonate. We will be looking at the decomposition of copper carbonate. So now, if you look on the notes that I sent you, I hope you were able to print them out. I left a space there for you guys to then be able, at the end of this presentation, I would want you guys then to be able to write the method, right? The method that is followed or the method that is used when you're conducting this particular experiment. I need you guys to be able to write the apparatus as well. The apparatus that are going to be used, I will be explaining them to you, or stating them to say this apparatus is for this one, this apparatus is for that one. So we need the apparatus, right? We need the aim. I already brought the aim for you. You need the apparatus. You need the method that is followed. You need also to record the observations that you make, and then the conclusions. And then the conclusions to say, so what do we conclude from this particular practical setup? Right. So now let us look at this experiment. Okay, so now let's look at what we have here. What we have here, this is an electronic balance. This is an electronic balance. It is used to measure the mass of objects. So we will want to measure, if we're going to bend some copper carbonate, we would want to measure how much copper carbonate we have used, right? And for us to know that, we are also going to see just now that we will have a test tube that will be placed into this beaker. Okay, let's just speed it up a bit, because right now it appears to be moving a bit slowly. Right. So observe that we have the balance. Right. We have the balance, and now let's pause it a bit. Let's pause it a bit. You then have the balance. Then you have the beaker. Then inside the beaker you have the test tube. Now, why has he done this, right, in this particular practical setup? There is something we call tearing. T-A-R, right? To tear, right? The good thing is that you guys are at home and you're holding these wonderful devices. So I hope you can be able to go onto Google and you Google to say, what is to tear, right? Some of these things, you now have the world at your fingertips. Don't let the lockdown lock down your brain as well, okay? You should be able to think to yourself, okay, Sir is saying tearing has taken place. It's not tearing as in tearing, it's tear to say when we want to record the mass of the test tube only. This scale has the ability to say even when we've put the beaker, we can then put it back to 0, so we can only record the mass of the test tube, right? So we'll record, already observe that we are using, we have an electronic balance, we have a beaker, and we have a test tube. You will also see other apparatus that we're going to use, okay? You will also see other apparatus that we're going to use, right? So now, that is the mass. That is basically the mass. This mass, that is written here, 30.21 grams. That is the mass of the test tube. Okay? That is the mass of the test tube. Why am I explaining all these parts? Because we have to be comfortable and we have to be familiar with practical procedure. I hope you guys understand this. Okay? Even right now, I need you guys to pause the video. Okay? You guys can pause the video right now, just maybe for a minute or 2 minutes, so that you can take time to really look at the setup and get to see the apparatus that are being used. Okay, so right now you guys are going to pause the video.